All right, so let's talk about the Ethereum transaction lifecycle in a nutshell. And I'm going to jump right in. So let's assume that we want to send one Ethereum from wallet 1 to wallet 2. So here's our wallet 1 and here's our wallet 2. So we want to send one Ethereum. So we're going to construct our transaction. We're going to first set our destination address, right? It's going to be wallet 2. Our value is going to be 1 ETH. And then we're going to also set a few other values. So first of all, we're going to have to give a gas fee, right? This is the actual amount of money that we are paying a validator to execute this code that's associated with transferring one Ethereum from wallet 1 to wallet 2. We have to pay for this code to be executed, and that's what the gas fee is. So this will be pretty small because our transaction is pretty simple, right? All we're doing is just sending money. And then we also want to give a tip. This is a separate fee that we want to give the validator to actually incentivize them to include our transaction in a block. Because when a validator is constructing a block, they have a lot of transactions that they can choose from. If we include no tip, then they have less of an economic incentive to actually include us, right? So we could just leave our transaction pending forever. That's not very good. So we'll say that we want to include some level of tip, and then we also include a few numbers like signature and nonce. I'm not going to get too deep into these, but for all intents and purposes, these are just some numbers that are used for validation of a transaction. So now what do we do with this transaction? We can't just send it to wallet 2. That's not really how this works. Everything is built on the blockchain, right? So what actually happens here? Well, we have to send this transaction to our Ethereum node pool, right? These are validators that actually run the Ethereum blockchain. They've all staked 32 ETH, so they're doing a lot of work. They have skin in the game, and they're going to process our transaction. So this is our pool of Ethereum nodes. It's across the entire world, but we're going to send our transaction specifically to one that's, say, most optimal for us. And this one is just going to be randomly selected, but we'll call it the entry point. Now, this entry point's responsibility is going to be to propagate our transaction to all of the other nodes in the pool. So it's going to do this via gossiping. It's basically like a P2P protocol, but we call it gossiping. And it's going to try to propagate this transaction to all other nodes, and all nodes are going to continue doing this until, ideally, our transaction is spread across the entire node pool. And it can be included in the blockchain most easily because almost every node is aware of it. Quickly, what does it mean to be aware of it? Well, a node has something called a mempool. A mempool is just an in-memory database of transactions that are pending. So it just basically has a list, right? Say our blockchain is pretty active. We have, say, 3, 4, 5, 6 pending transactions, and then our own transaction is our 7th transaction. So now, this mempool is basically just like a waiting room for transactions. Nothing really happens from here until a node has actually proposed a block. So now we just wait until one of these nodes is ready to propose a block. Now, there's some underlying mechanisms that happen with this. I'm not going to get into that, but let's just say that this node is chosen to propose that block. So if our blockchain looks like this, right, it's say a sequence of historically linked blocks. Again, a block is just a ledger basically of things that have been executed in the past. So it's just like a record of all transactions. But let's say this is our Ethereum blockchain. Okay, this is Ethereum, but this is our blockchain, right? This node is going to want to propose some kind of block here, right? And what's it going to do? It's going to take all of these transactions that are pending in its mempool, and it's going to execute them sequentially. Now, again, this execution is paid for by the gas fee that we included in our transaction, right? So each of these transactions will have included some gas fee and some tip, and they're each going to get executed in sequence. And then the result of this is once they are all executed, now the final state is going to be written into a new proposed block by this block proposing validator right here. So it's going to write our new block here, and it's proposed, right? So it means that our transaction is on its way to being finalized, but it's not finalized yet. In fact, it's only confirmed. Once this node has actually proposed this block, now all of these validators, not all, but let's say for the sake of simplicity, all 6 of these validators now have to check that this block is actually valid. So what they're going to do is they're going to re-execute everything that this node did, right? So they're going to rerun transaction 1, 2, 3, 4, 5, 6, and 7 to make sure that all these transactions run properly and that this block that was proposed is actually a valid one, right? So all 5 of these new validators are going to have to do it, and once they all agree, then we're good to go, more or less. So now our block is confirmed, but it's not finalized. So what do we have to do to actually finalize it? Well, Ethereum finalizes blocks in batches of 32. These are called epochs. And basically, our block is somewhere in some batch, right? So let's say arbitrarily, right, the chain has been running, let's say it had 14 blocks prior to ours. Ours is number 15 right here. And now it has to do 17 more blocks after ours, right? So now, our block is confirmed, but it's not finalized. So the Ethereum blockchain is going to continue chugging along, maybe like for block 16, it's going to choose like this one as the validator. Now it's going to do the same process as I described. It's going to propose a block here, etc., until we get to, the final 30-second block. And once all of these have been proposed, and once all of them have had enough, checks across them to ensure that they're valid, now the blockchain is going to sum up all of these checks and ensure, is every block here valid, right? So assuming all of them got a 5 out of 5 on the validity score, they could have some errors, but let's say all of them are perfect. Now the blockchain is ready to commit these changes, right? And what it's going to do is now set a new checkpoint here. So now this 32 batch is actually confirmed to being a final part of the blockchain. We don't have to ever change it again. And this is what it actually means to have a transaction finalized. And from this point on, now your transaction is completely finalized. And now officially, wallet 1 has 1 less ETH, wallet 2 has 1 more ETH, and wallet 1 has a record of sending that 1 ETH, and wallet 2 has a record of receiving that 1 ETH. Now, there's a lot more that kind of happens here under the hood in terms of how validators are chosen, how finalization actually happens under the hood, right? But overall, this is kind of the high level, and that's basically Ethereum transaction processing in a nutshell in terms of lifecycle. So I hope that was helpful. Thanks for watching.